Hi, I am Haziq. Okay, now I will talk about the Tanagra introduction. Okay, Tanagra represents free data mining software for academic and research purposes. It provides several data mining methods from exploratory data analysis, statistical learning, machine learning, and databases area. The main goal of this project is giving researchers and students easy to use data mining software, and second goal is to purpose to researchers and architecture, allowing them to easily add their own data mining methods to compare their performance. In order to letting users going to the essential of the work dispensing members dealing with data management, Tanagra acts more as an experimental platform. The last goal of this platform is diffusing a possible methodology for building this kind of software. Okay, now we move on to the installation guide of Tanagra data mining tools. So here is the website. I pasted the link in the Microsoft Word. So first we go to the download, and okay, go to this setup. Here setup. Okay, wait for a minute. Okay, and then we check in the download. Okay, here is it. So first double click and accept the agreement. Next, folder. I used to put in D drive because my D drive is have a lot of space there, so it's up to you. Yes, next, install, finish. Okay, this is the layout of the Tanagra program. So finish the installation guide. Okay, next we move on to the basic function in Tanagra data mining tools. So the first one is how to import the data in Tanagra. So first one, we just click here on the top of the tab here, file, new, and then we browse the folder that we want to look. Okay, there are various of the files type. So here we normally use the XLS files lah, Excel files ni 97 and 2000. Okay, we search, and then here there is one file named the Olympic athletes. So click here, open. Okay, okay, now the dataset is the dataset was imported here. So next function is standardize, or we also call it transforming data. So Tanagra will execute certain transformation. Tanagra enables user to discretize continuous variable using equal frequency, and as a result, certain types of regression that are only available for discrete variable are now feasible. This is for use of supervised learning functions, and the data may be divided into training and testing sets. Okay, standardization. First of all, we need to click here the icon on the top of the page. So the input tab, I will choose age and total medals, and the target I choose country. Click OK. Okay, now we already define the status. So to make it standardized, so we go to here, component at the bottom of the page. We search for the where is it? Under the feature construction, and this standardized, just drag to this define status, double click, and then we can see the result. and the parameter shows the formula. Okay, that's all for the standardized. Next, I will show you how to do the visualization of data. Of course, in application, we after we do something, we need to know, we need to visualize what we are doing right now, and we want to see the result of the action that we do in this data mining tools. So to do the data visualization, here we can before that, if you want to do the k-means, just click the k-means and drag to the define status, and then we can visualize it. Just click here data visualization and click view dataset and drag into the k-means, so we can see now the dataset. Oh, can I? Okay, okay, this is the don't worry, there are many options of under the data visualization. So if you want to see the scatter plot, click and drag into this view dataset. uh, and then you can see here, and then there's options here. If you want to see the total medals of the scatter plot, and then you can make the conclusion from this scatter plot. Okay, that is for the visualization of data. Okay, next we move to the how to export the data. Okay, Tanagra's data exporting feature is located basically and under the segment of data visualization features. So the exporting data allows you to store it for further use or to be accessed by another application. And this could be helpful if you discretize variables and needed to store them in their current shape, or if you just wanted to save specific samples or variables. So to export the dataset, you can see under the components and data visualization, there is export dataset. So click and drag to the, where is it? Define status, I guess. Okay, click here, and to export the dataset, we actually can modify the parameter. So here there are a lot of selection and options. These all attributes will display all of the attributes in the dataset. And if you want to choose specific, just like target and input attribute, just click this and okay, and then this is the file name. Okay, and then click view. Okay, this okay, it will save in this file path, so we can see lah here downloads. Okay, the output. Okay, this is the sample of the output lah I want to show. Alright.
Hi, my name is Rasmin and I will be explaining on how to do association analysis and regression analysis in Tanagra. Okay, so this is the data set that I'll be using to perform association. So I'm going to put it. Then I'm going to import the file. So we need to change the file type to Excel. Okay, so here is the file information. So it says that got 6 attributes, but actually we only have 5 because the tag count of customer, but it's not an attribute. So to do that, we need to click define status. So then we need to you can see it choose customer here. Then we need to, so our input is milk, tea, sugar, bread and coffee. Then click OK. Then right click and execute. So now we can click view. Yeah, so you can see we got 5 attributes. So now we can begin to do the association. So first, click association, click define status. Then, so for association we need support and confidence. So right now I will do the support parameters. Click frequent set, and then you need to drag it to define status. So here you can see that the line come from define status and not dataset. Then you need to right click on parameters. Then you can key in your support parameters detail. Click OK. Then execute. Then you can click view. So it shows that this one got 2 item, got 3 item also. So for example, if you want it to be only 3 item, you can parameters 3 and you put max 3 also. Click OK, execute and view. So it only shows the frequent set for 3 items. Then I'm going to put it back to normal. So this is the one that I want. Okay, so the next thing you need for association is confidence. So for confidence you need to click a priori and drag it to frequent item set. Then click parameters. So just now the support we put is 0.2, confidence 0.5. So the max item set is now we put is 5. So we haven't do lift, so we just put 0. Click OK. Then execute view. So here is the result. So this is the rules obtained by the confidence. So when you buy bread, you buy milk also, the confidence is 100 and the support is 30. So when you buy sugar, then you buy tea, it's 62.5. So we have three item set that got confidence 100. So if you buy tea, you will buy sugar also. If you buy milk, you will buy sugar also. So yeah. So that is all for association. Thank you. Okay, so this is the dataset that I will use to do regression. So it just contains the result for exam 1, 2, 3, and this is the finals. So first, you need to import the file. You need to change it to Excel. So once it opens, you need to click define status. So I'm only going to use exam 1, 2, 3 as input. And then click on it again. Right click and click parameters. Then I'm going to choose final as the target because I want to predict the final result from exam 1, 2, 3. Then click OK. Then you can view. So you can see input is exam 1, 2, 3 and the so you can see that the input is exam 1, 2, 3 and the target is the final result. Then so we go to regression here. and we are going to do multiple linear regression, then you just drag it to define status. So this one we don't need to input any parameters, so we can just click view. So now as you can see, the endogenous attribute is final. It means that the one we want to predict, and the coefficient is 0.989, which is very good. So it shows that the exam 123 can predict the final result. So here is the full analysis. For the PLS regression, I'm going to use a different dataset because just now the attributes not enough. So I'm going to use this dataset. So as usual, you need to import your dataset. Then I'm going to define status. So all this will be the input. And the target will be consistency, price, and symbolic. And just click view. So everything is correct. Then we click on PLS and click on PLM regression, and you drag it to here. Then click parameters. So number of axes, I'm going to put 3. So here you get the result. Number of axes 3, and all of this. So that is how you do PLS regression in Tanagra. So this is it basically shows the variance for each attribute and the redundancy. This is on target Y. So our Y was the 3 targets that we choose to predict, and this is our x-axis. So that's it for PLS regression.
Hi everyone, I'm Shasita from Group 11 and I'm here to explain about the functions using the data mining tool given to us, which is Tanagra. Alright, the first function that I'm going to demonstrate to you guys is the k-means clustering algorithm. So this algorithm assigns the data points to a cluster such that the sum of the squared distance between the data points and the cluster's centroid, which means the arithmetic mean of all the data points that belong to the same cluster, is at the minimum. So the lesser the variation between all those different data points in the same cluster, the more similar the data points are within the same cluster. Alright, with that, we can get started with the demonstration. So firstly, after launching the Tanagra, which I've already done, you have to click the open button right over here, click file, and then click new over here, and then it will allow us to create a new diagram inside the data mining tool. So here we can name our diagram. So let me name it as demo1, and then the data set, I have placed my data set in the desktop. So the data set that we are going to use is cars_dataset.txt. So let me go and open it from my desktop. Alright, so once you have opened it already, then we can click OK right away. So it will extract all those data set into data mining tool itself. As you guys can already see, we have 392 examples inside the data set that we have just extracted, which has 6 different attributes inside there. which is MPG, displacement, horsepower, weight, acceleration, and origin. So all these are continuous attributes, and this one is a discrete attribute. So once we have done this, we can go into our next step, which will be to obtain an overview of the characteristics of the dataset. How we are going to do it is, first we need to add define status component into the diagram. So as you guys can see, this colorful icon over here is the define status icon. So we have to add this component inside, and it will have a pop-up like this. So in this pop-up window, we need to set all those continuous variables that I've shown just now. These continuous variables, we have to put it under the input, which are the active variables during the analysis. So we have MPG, displacement, horsepower, weight, and acceleration. We can move it this side, and then we can click OK right away. So in order to launch the define status component, you can double click, and then it will straight away show us this pop-up. As you guys can see, the inputs of all 5 continuous variables are already here, and we are ready to go. Alright, now let's keep it going. Let's move to the next step. In order to detect any possible anomalies inside our data set, right, we need to have a special prerequisite requirement. So how we are going to do it is, we have to click on the statistic tab under the components bar, and we have to click on the more univariate continuous stat component over there. So we go and find it over here. Where is it? Yeah, over here, more univariate continuous stat. You just have to click and drop it over here. So after we have drag and drop that component, then we can move to the next step, which is to standardize. So how we are going to do it is, we double click, then as you guys can already see, all those different attributes that we have inside our data set, we will be able to have the statistics of each attribute. As you guys can see, for MPG, we have the average, the median, the standard deviation, we have the skewness, the kurtosis, as well as the histogram at this side, for all those 6 attributes that we identified just now. I mean the 5 different attributes. Yeah, so once we are done with this, we can proceed to the next step, which is the third step. Standardize the variables in order to eliminate any inconsistency or discrepancy of scales between the variables before performing the clustering. So how we are going to do that is by adding the standardized component from the feature construction tab. Right, let's go and find it. Where is the feature construction? Over here, and we are going to identify the standardize. Let's take standardize and put it over here. Yeah, alright, we already have standardized over here. Then what we're going to do next is 5 new attributes are available for the k-means processing. So once we have put it over here, we have to double click, and as you guys can see, we have 5 different new attributes, which are the standardized attributes inside the data set, ready for us to proceed with the data processing. Yeah. Alright, so our next step will be to insert a new define status component into the diagram and set the input as the newly computed attributes that have been standardized earlier. So all these new standardized attributes will be selected under the input for the newly computed attributes. Alright, let's click define status, and we bring in all those new attributes. 1, 2, 3, 4, 5. Alright, we move, and we are good to go. Alright, here we go. We have all our inputs as the 5 new attributes that we have just computed, the standardized attributes. So next step will be to add the k-means component from the clustering tab. Then click on the parameters and set the following parameters. Okay, we have to add the k-means component from the clustering tab first. Where is the clustering tab? And we have k-means component, right? Drag and drop. So once we have done that, click on the parameters and set the following parameters. Okay, k-means, we right click, and then we click on the parameters, the k-means, and then we change the parameters to this 2, 10, 5, and then we have to change this distance normalization to none, and then average computation is the same, and then random generator is standard. Okay, then we can click OK. So once we are done, we can click on the view menu click on the view menu. Yep. So as you guys can see from the parameters, we have got two clusters. The next iteration is going to be 10, and the trials is going to be 5 different trials. Yep. So from the evaluation itself, we can see our R square is 57%, and the sum of the squares is 831.6074. Yep. And we can even see more data over here. So you can see the total sum of the squares, which is over here. Total sum of the squares of all the data sets, and then we have within sum of squares over here 831, and then between sum of squares over here, which is the 1954 minus 831. All right, so we can proceed to the next step already. The cluster centroid, as you guys can see over here, the cluster centroids gives the average for each variable according to the cluster. So as you guys can see, so for this new standardized attribute, we have cluster. For those two different clusters, we have the average for each cluster. Yep. All right, let's proceed to the next step, which is to interpret the clusters as a whole. So for interpretation, we have several steps inside this function alone. So first is to group the data points. So to identify and label each instance inside the dataset, you have to click on the View Dataset component from the Data Visualization tab. So Data Visualization tab, View Dataset. Yep, View Dataset. Alright, so next will be descriptive statistics. So when we click View Dataset, we can be able to see each and every dataset inside our each and every instance inside our dataset. Yeah. Alright, so next step will be the conditional descriptive statistics. So this allows us to understand the main characteristics of each of the cluster in the dataset. So in order to do this, we have to first bring in a define status component, and then set the column cluster k-means 1 as the target. So we have to go to target, then cluster k-means will be over here in the target, and then all the other attributes as the input, including the illustrative variable origin. Okay, so all the other variables attributes we have over here will be under the input. Yep, let's go and do it. PG, displacement, horsepower, weight, acceleration, together with origin. Okay, let's put it inside input, and we are good to go. Then we can double click define status, which is also means viewing. So as you guys can see, it's the same. The results is everything that we have clicked, put it inside input, and here we have put it inside the target. Alright, let's move to the next step, which is to add the group characterization component from the statistics tab. So we go to the statistics tab, group characterization is right over here, so we put it over here, drag and drop. Okay, next will be cross tabulation. So before that, we can view our group characterization, right? So we view. So as you guys can see, it has grouped into both these two clusters, and it has its own numbers for each of the attribute inside each of the cluster. Yeah. Next is cross tabulation between group membership and illustrative variable. So this is to highlight the association between the cluster membership and illustrative variable using cross tabulation. So how we are going to do that is we create a define status component, and then set the origin target. We set the origin as the target, and then C k-means 1 as the input. Cluster k-means 1 as the input, and target is origin. Yep, we are done. Then you can view it. So once it is ready, we can go to the next step, which is add contingency chi-square component from the non-parametric statistics tab into the diagram. So from the non-parametric statistics tab, we add the contingency chi-square component. Non-parametric statistics, contingency, right? Yeah, contingency chi-square. Contingency chi-square. Yep, right over here. Done. And then click on the view menu. Yes, you guys can see the contingency chi-square, where we already have the origin and the column cluster k means 1. Next is click on the view menu, where we can see the contingency chi-square for each of the clusters and then the sum according to the countries. Yep. Alright, next is we are going to create a scatter plot out of our clusters. So what we are going to do is we are going to add the scatter plot component from the data visualization tab. Then click the view menu. So from the data visualization tab, we add the scatter plot. Data visualization, scatter plot. Add in here. So you can move this a bit. Yep. Alright, so once you have added our scatter plot, so click the view menu, set weight on the horizontal axis and horsepower on the vertical axis. So let's view. So over here, we need to change everywhere. Click set weight on the horizontal axis. So weight will be on the horizontal axis, right? This horizontal axis. I'll click weight, and then horsepower on the vertical axis. Over here we put horsepower, so on the vertical axis. Yep. And then use cluster membership to colorize the points. So the cluster membership that we have over here, so we can see this dot, circle red color is the cluster k means 1, and then the triangle green colors are cluster k means 2. Yep. Alright, let's proceed. This will be the scatter plot that we have come up with through the dataset. Alright, next we'll be exporting the dataset together with the cluster column. So how we're going to do that, we are going to export it. So specify the columns to export using the define status component. So we add another define status, and then we specify all those columns that we are going to export, right? So we set all those columns that we want to export at the input, the original variables, and the computed column. Yep. So the input will be all these things. Yep. Then target will be cluster key means. Okay, once you're done with this, we can click to view. Yep. Click to view. Yeah, it's the same, and then we can proceed with the next step, which is to add the export dataset component from the data visualization tab. So from the data visualization tab, we add the export dataset. Export dataset over here, we bring drop over here, export dataset, and then in the settings dialog box, parameters menu, specify that only the input attributes must be exported. Also define the directory and the file name. So we click the settings box, parameters menu. So specify that only input attributes must be exported. How? Attribute selection is input attributes. Yeah, and then define the directory file name. So how we're going to do it is we put output for demo1. So output demo1.txt. Alright. Yeah, all examples and input attributes. Alright, all good to go, and we can click OK. So once we double click, which is also means view, we'll be able to see a new file will be created, a new data file, output.txt. So for our case, will be output demo1.txt with 392 observations and 7 different variables is created. Okay, here is a summary where all the attributes are selected, all the examples are also selected. We have exported 392 examples with 6 different attributes and the file name over here. Alright, let's get started. So now I'm going to demonstrate the second function in the data mining tool Tanagra. So it's going to be a random forest analysis algorithm, which is a supervised learning algorithm. So the general idea behind this random forest analysis is the bagging method, which is a combination of the learning models, which actually improve the overall result towards the end. Alright, with that we can get started. So the first thing that I'm going to do is to create a diagram and import the dataset. So click this icon over here, not file, click this icon and then click we are going to import a binary data mining diagram, so BDM, and then you can go search the file that you're looking for. So the file that I'm looking for is drhud.bdm. So click and then I can open the file already. Alright, so as you guys can see, there's already several steps already over here. So the first thing that I'm going to do now is I have already imported the dataset. Next, I will be going into the define status. So for the define status, I need to click over here to create a define status and choose the target attribute. So my CO, EUR and the input attributes are all will be inside the inputs over here. Yep. So my target attribute is going to be this one, and my input attributes is everything else. So once done, put it over here and we are good to go. Okay, so my define status is ready, as you guys see over here. And then we can move to the next step, which use C4.5 and cross validation in order to evaluate the accuracy of the standard deviation of the tree algorithm. So how we are going to do that is we are going to use the cross validation. So go into supervised learning and then click C4.5. Yes, over here. Alright. So once we are able to click over here, you will be able to see accuracy of the dataset. So you guys can see the error rate is 13% and the value prediction according to the presence and absence is about 16 and 11%. Alright, what else we can identify over here is the binary tree description. You can see the number of nodes, the number of leaves inside the dataset, and yeah, for the data description we have 12 different descriptors inside there. Yep. Right, with that we can proceed to the next step, where we the next step will be to implement the random forest algorithm. So what we are going to do is we have to insert the bagging method from the meta supervising learning tab, then embed the R&D tree component from the supervised learning tab. So first we have to include the bagging into meta supervised learning tab. So meta supervised learning tab, and we bring in bagging. Yep. So once done, using the algorithm without an aggregating framework often gives poor performances. So as you guys can see over here, according to the classifier performances, it is very low error rate, with the number of classifier is 25. So for each classifier you guys can see the performance, which is represented by the error rate. Yep. So in order to improve this performance of each of the classifier. So we are going to add another tab inside there. So what we are going to do is evaluate the accuracy with the cross-validation component from the supervised learning tab. The error rate will be 21.48%. So cross-validation component from the supervised learning tab. Cross-validation. Evaluate the learning accuracy with the cross-validation component from supervised learning tab. The error rate will be 21.48%. Yep. So we need to bring in a cross-validation component. Let's see where it is. Oh, it's not here. Oh, supervised learning assessment. Cross-validation component. We bring it in here. So once we have bring in that one, wait, let me delete all this. So for cross-validation, we bring in and then we double click to view, and as you guys can see, the error rate will be 21.48%. So you guys can see the cross-validation error rate is 21.48 minimum and maximum. Yep. So we have done only one trial, so the error rate can be shown for only one trial. Yep. So with that, we can proceed. We can show through this demonstration about the random forest analysis. Alright, now we are going to look into the third function that I'm going to demonstrate, which will be the knife bias classifier. So a knife bias classifier is also a machine learning model. So it is based on the bias theorem. So using the bias theorem, we can identify the probability of A happening based on the occurrence of an event B. So B is the evidence and A will be the hypothesis. This is an assumption made on the specific event based on the occurrence of another event before this. Alright, with that we can get it started. So firstly I have to create a diagram and import the dataset. So the dataset that I'm going to use is breast.bdm. Alright, I'll click, I need to click over here, open file, and then click desktop, and I have to search for binary data mining diagram BDM. Yep, over here, open. Yep, and it's already inside here. So with that we can get it started. So I have to select the contextual attributes, which will be the class attributes, and continuous attributes to discretize. So the continuous attributes will be input and the class attribute will be the target. Okay, so I have to insert a defined status, and then over here all the continuous variables will be input and the class attribute will be the target. Okay, target, class attribute will be the target, everything else will be input. Yeah, so target is class, input is everything else. Okay, yeah, got it. So once this is done, we can move to the third step, which will be insert MDLPC component from the feature construction tab into the diagram. The component works only if all the inputs are continuous. There's only one target discrete attribute. So as you can see, this is a discrete attribute which is inside target, and all the others are continuous attributes which are under the input. So we are good to go. So let's insert MDLPC component from feature construction tab. So we go to feature construction and we insert the MDLPC. Yep, MDLPC. Okay. Done. So once this is done, we can execute the component to obtain the discretized attributes. Okay, let's take a look. So as you can see, we have got 9 discretized attributes. So from the source attributes that we have imported from the data set, we have new attribute which are already been discretized. Okay, alright, what else we can understand over here? Yep, done. So let's move over to the fifth step, which is to insert the define status component again, then set class as the target, new input attribute as the discretized attributes. So we insert define status again, and here class will be the target. Class target will be the class, and the inputs will be new input attributes of the discretized. Okay, so everything over here, the green color ones, will be inside inputs. Okay, and we can define status. Yep, done. So once this is done, we can go to the sixth step, where define the learning procedure with knife bias classifier by inserting the supervised learning component from meta supervised learning tab. So we go to the meta supervised learning tab and we insert supervised learning. Supervised learning. So once we have done this, we have to wait. Next, we have to incorporate the knife bias component from supervised learning tab as well. So from supervised learning tab, we have to bring in knife bias. The knife bias over here, bring it into the supervised learning. So once done, we can incorporate and we can click view. We can click view. Yep. So as you guys can see over here, the classifier performance show that the error rate is less than 2%, and then at the beginning and malignant stage of the classifier, the performance is also quite low. Yep. According to the data description at the beginning, the percentage is 65% and the malignant stage will be 34%. Yep. So with that, we can move over to the next step, which will be the seventh step. So as you guys can already see over here, 0.0286 is the error rate. Okay, so with that we can add a cross validation component from the supervised learning for the default parameters. So we go to the supervised learning and we insert cross validation. Supervised learning assessment, we bring in cross validation. Yep. So we have cross-validated the data as well, and still the error rate is almost the same, 0.029. Okay, so once this is done, we can move to the next step, which is the results obtained, where we can compare this result obtained with the other supervised learning algorithms that we have done previously, to see which one has more accurate or more efficient results in terms of its relevancy with the error rate. Yeah, with that, this is all for the knife bias learning algorithm. Thank you.
Hello, my name is Mohammed Shakir Mehdi. So in my part, I'm going to talk about how to make a tutorial for making the decision tree and also the support vector machine in the Tanagra.
The tutorial is, first we need to make a new diagram first, so we need to create new. Then we choose the dataset. It can be TXT file, ARFF, or XLS file. So first we import the dataset. So we choose here, for example, we use sonar.xls in the XLS file. So here is sonar. So then we click. Then we should get the data here. We get the dataset, the parameters, the result. So now we click to we want to define the status, so we're going to define it. All attribute here will be the input, so except for class. So then this will be for the input, and for the class going to be at target. Right, so then we click OK. So then we execute, then you can see here input is 60 and the target is 1. So then we can see here the result here. Alright, so next is we need to make the linear discrimination analysis. So then at the bottom here, we can see here in all the components here. So we can go to the SPV learning. So we can see here in the linear discrimination analysis, we drag and put here in the define status. So then after that, we click the linear discrimination analysis and we should get the error rate, and it displays the error rate and values prediction, and also the metrics, also the characteristics, and so on. Alright, so as you can see here that the substitution error is 0.10, it's mean 10%. So since it is only bias estimator, we need an honest error rate estimator, which is why we select a bootstrap in the SPV learning assessment. So if you want to click the bootstrap, we can find bootstrap here at SPV learning assessment, click the bootstrap, and we put it here. So then we click execute. So the bootstrap here shows the bootstrap here. So it will produce the error rate, which is 0.25.44, or we can round out as the 25%. Okay, so for the next tutorial is I'm gonna make the tutorial for making the decision tree in the Tanagra. So first, as usual, we create a new diagram. So as usual, we select our data sets, so we import. So this time I'm not going to use the XLF file, I'm using the TXT file. So I need to find the with 500k.arff file. Yep, alright, so then click OK. So it's gonna take a while. Alright, so we get the data set here, the name of data set. It can be anything in the data set. This is just the example. But I want to show that we can choose any type of file. We can use even the TXT file or maybe the Excel file and so on. So we get the result and the parameters here, and also the attributes and the 5. So we can see here you get the 500,000 example. Sorry. Alright, so we'll start it. So now as usual, we define the class and target. So we go here, and as usual, class will be the target. So we put the target, and for the input, it will be all the so here attributes here. So we're gonna click OK. So after that, so we already defined the attribute. So now we want to execute the SPV. So we go to the SPV here, supervised learning. We go to the C4.5. It's here, C4.5, which is about the target of discrete class attributes, one or more discrete. Alright, so we drag here to the define status, and then we right click, and the first one we need to justify the parameters. So we go to the supervised parameters. So minimum size of leaf, we need to make it, for example, I make it 1000. So 1000, so and the coverage level is 0.25, so then we click OK. Alright, so now it's making the process, so we need to wait for a while. So now as you can see, we got the decision tree for the supervised learning here. After the execution, if the process already execute, it should be the blue color one in the play one here. So we can see the characteristic, data description, tree description. We can see number of nodes is 233, number of leaf is 170. So we can see all the V here, V7, V11, V16, V12, and V16, V12. Alright, so this is the decision tree. So you can see all the way down here. So it shows the computation time and also when we created this decision tree. So thank you very much. That's all for my part. Thank you.